right, we're going to talk about the LSRL, and we're going to talk about how we can use it to predict, how we ought to interpret it, and what it means to extrapolate. So if you take a look with me right here, sorry, my pen's lagging. There we go. The least squares regression line. We call it the least squares regression line. That's what LSRL stands for, okay? It is a prediction equation. It predicts a value of y for a given value of x. And what we do is we fit it to a scatter plot. So we have a bunch of scatter dots that we talked about. There's a line that seems to fit it best. And mathematically, the least squares regression line is the line that fits it best. And we'll talk more about what that means in the next video. But right here, we want to write it in this general form. Okay, I know we normally write y equals mx plus b. Well, AP Stats, they do it a plus bx. And what they actually do is they call this first one b0 plus b1x. All right, and so when you see it on your formula sheet, you're going to see a b0 and a b1. Okay, and this y hat, you read y hat, but this means predicted y, okay? And this is going to be huge, in case you can't tell by me saying predicts, okay? It's not the actual y, right? When I did my data, when this was my x, this was the actual y, but this right here, right? So this height here is the actual y. This is the predicted y. And so we put the little hat on it, okay? So the difference between actual and predicted, this is an equation of what the line predicts your y should have been for your x. And if you're a little bit below or above, that's fine, but the line is a prediction equation, okay? It is a prediction equation. It predicts the value of y given x. So when we write a least squares regression line, we don't want to write it as y equals, we want to write our y in context with a hat on it. You just write the word, right? If you're predicting number of dollars or people, or, right, you can put people hat or time hat or whatever hat, okay? A plus B, and these will be numbers that you'll be able to fill in. And then you put your x in context too. Otherwise, if you write this just as y hat and this just as x, then you need to define y hat is, and you got to write it on the margin, y hat is, and tell me what it means, and x equals, and tell me what it means. You need to define your variables, or you can just use the context itself as the variable. Now, how do we interpret slope? Well, you probably understand slope to be rise over run, which I say delta y over delta x, but in this case, it's a delta predicted y over delta x. Delta, in case you're not familiar with that symbol, means change, difference, okay? y2 minus y1 is the difference in y's, so we call it delta y, all right? The difference in y's, and what we want to do is interpret it in context. So you can literally write your sentence interpreting this, because that's what we want to talk about, interpreting slope, okay? So as my x changes by 1 unit, my y is predicted to change, and really you should say increase if b is positive, or decrease if b is negative, by b units. And that will perfectly form your sentence. And so I literally, when my x is predicted to increase by 1 unit, so I just make a sentence out of all of these. When my x increases by 1 unit, my y is predicted to change, which is increase or decrease, by b units. And that's how I'll write my sentence of interpretation. It's literally using that sentence that I've drawn right there, okay? So if you look, as x increases by 1 unit, as x changes, increases, this is, if you have a negative fraction, you just put the negative on top. As you rise, you don't put it on top and bottom. So this will always be positive. So as x increases by 1 unit, y is predicted to increase by b units. And you want to make sure that when you say x and y, you put those in context. All right, and we'll see an example of that in a minute. Now the y-intercept. What is the y-intercept? Well, it's literally the point 0, a. in this case, it's an A. I know we normally think about it as mx plus b. And I'm going to put a hat on A if my pen stops glitching. Okay. Maybe. All right. So if I call it a hat, all right, then I can read this and put it in context, give it some variables, and I can answer this question. When x, see how that's x comma y? When x is 0 units, my y is predicted to be a units. And I want to, once again, not use the letter x and y because then you're leaving out the context. So when the whatever shoe size is 0, a size 0, y is predicted to be, your height is predicted to be so many inches tall, okay? Because we can use shoe size to predict height, okay? So whatever it is, all right? Your x is in context, you tell me the number of units, and y is predicted in context. Now, this is always meaningful and makes sense in the context of the problem. This is always meaningful, but sometimes doesn't make realistic sense because could I have someone with a size, do shoe sizes go down to size 0? I don't believe so. In which case, it might be weird. Or like if you find a y-intercept, like if you go back to the year 0 and you predict the United States' population or something like that, you might go back to the year 0 and find that there's a negative population, especially if you use a linear graph and you use like 2020 as like the starting year, or the year 2000 as the starting year. If you go back 2,000 years, you might be in the negatives and you'd say, oh yeah, when it was the year 0, the population of the United States was predicted to be negative 580 million. And you'd be like, yeah, that's dumb. It always has a meaning, but it's not always one that makes reasonable sense. Okay. So interpolation versus extrapolation. To interpolate is to make a prediction within the range of your x's. To extrapolate is to use your least squares regression line to make a prediction to say, oh, well, my x's go from a little bit above 0 to about 40. But I'm going to make a prediction. I'm going to assume that this is going to stay linear. I have no evidence that it's going to stay linear. Maybe it's flattening off, and my prediction at 60 is going to be way off because it's actually, or maybe it's a downward facing parabola and it's going to start dropping down or something like that. Like, or maybe it's skyrocketing and it's growing exponentially like coronavirus, right? Look at that guy up high. Maybe I should be fitting it with a curve thing. And by using a line, I am extrapolating and I'm expecting this pattern to continue beyond my data set. Any prediction you make beyond your data set is extrapolation, and it's dangerous, okay? So let's just do a quick example of a question. So this is ice cream sales at different temperatures, okay? And you can see the least squares regression line goes through the cloud of points is really what you're aiming for, and we'll talk about that more in the next video. But if I want to interpret the slope, I want to write it like this. Predicted sales over temperature equals my slope over 1, and I put units, dollars and degrees Celsius. And so I would say for each increase in 1 degree Celsius, the sales are predicted to increase, because it's positive, by $1.51.8. Okay? And so you can see my sentence right over here. For every 1 degree Celsius warmer that it gets, okay, that's just talking about the bottom, ice cream sales are predicted to increase by $1.51.8. Okay, the y-intercept, okay, 0 comma b predicted, okay, is 0 degrees Celsius and $3, or basically 30.5 cents. And so what I would say is, when the temperature is 0 degrees Celsius, the ice cream sales are predicted to be 30.5 cents. Okay, and this might be like an ice cream truck. Okay, really hot days, the ice cream truck sells lots of ice cream. Cooler days, you don't sell as much ice cream. If it was freezing, because right, that's freezing in degrees Celsius, then you would expect to drive around your truck, and over the whole day, you'd sell 30 cents worth of ice cream, is what this equation is predicting. Okay, notice that is an extrapolation, which is part of the reason why it doesn't make sense. Okay, so if the temperature is 0 degrees Celsius, then the sales are predicted to be 30 cents and a half. Okay. If I wanted to make a prediction of at 16 degrees Celsius, how much money can you make? It would be right up here, and it would be just over $300. If I wanted to make a prediction of at 30 degrees Celsius, how much you would make, I would be predicting over here, and I would be extrapolating, because anything above this like 25-ish is an extrapolation. Okay? So those are the ideas in this unit. I know that was a lot, but it's so helpful. Predicting slope and interpreting slope, prediction line, interpreting slope, interpreting y-intercept in context. Good luck.